So this section is about determining limits using algebraic manipulation. For this section, your factoring skills will be put to the test. You are going to be writing equivalent expressions for a function and using that to determine limits. So first off, every time you do a limit, the first thing you should try is just substituting. So you should try plugging your number in. So for this particular limit, I'm doing the limit as x gets close to pi over 4. Well, it turns out that sine of pi over 4 exists. Cosine of pi over 4 exists. And when I multiply those two answers together, they exist too. So root 2 over 2 times root 2 over 2 would be 2/4 or 1/2. So for that particular limit, the substitution method worked just fine. I was able to just substitute the number in. There's no discontinuity there. There's no problem with just plugging in the number. This next one, go ahead and pause and try it yourself, but we're going to do substitution again for this next problem. So we plug in 4, we get 0 on top, or 4 minus 4, which is 0. And then we get 16 plus 2 in the denominator, so we have 0 over 18. And we know, one math fact we know for sure is you can't divide by 0, but there's no problem with dividing 0 by a number. So this limit is 0. 0 is a perfectly good answer. It just means that the y-coordinate is 0. Okay, so that's the first thing you should always try. Try plugging your number in. It might just work. If it works, the way you know it works is if you get a number for an answer. Sometimes when you plug in your number, when you do your substitution, like for this example, I get 9 minus 15 plus 6 over 3 minus 3. So I have negative 6 plus 6, which is 0 over 0. 0 over 0 is called an indeterminate form. And when you have an indeterminate form, you can not just say the answer, you have to do more work to get the answer. 0 over 0 doesn't mean the limit doesn't exist. It means that it's indeterminate. The way you figure out the limit is you try to write an equivalent expression. The way you do that is with factoring. So if I look at my numerator here, I have a factorable quadratic. It would be x minus 2 times x minus 3, which multiplies to make positive 6 and adds to make negative 5. And then I have x minus 3. So if I take the limit as x goes to 3 here, my x minus 3's are in both the numerator and the denominator. And we can cross them out because remember, we don't want x to be 3. We want x to be close to 3. If x were equal to 3, we'd be dividing by 0. It's not equal to 3. It's just close to 3. So we can cancel out that factor. And now we can do substitution and we get 3 minus 2, which is 1. Okay. Notice for the next problem that plugging in 0 would give you 0 over 0, which is that indeterminate form again. So try factoring and see if you can come up with an answer. After you've tried it, go ahead and unpause, and I will work through my work. So I see a GCF in the numerator, so I have x times x minus 4, if I factor that out, over x, and I have the limit as x goes to 0. So now these two x's can cancel because remember, x is not 0. X is close to 0, but it's not 0. So now I can plug in my number. I have 0 minus 4. So that means that my limit is negative 4. I strongly recommend that you continue writing this limit down each step of the way. The College Board will look for it as they're grading your paper, but it also helps you remember, what the heck am I substituting for x? I get to x minus 4, then what do? Well, then I do my substitution. So just be careful about rewriting that for each step of your problem until you make the substitution, and then you don't have to write it anymore. Sometimes our equivalent form is a little bit less obvious to find. If I substitute 4 into this equation, I get 2 minus the square root of 4, which is 2, over 4 minus 4. So I definitely have an indeterminate form. I definitely have 0 over 0. So I'm not done, and I have to figure out what to do. You have multiplied by conjugate pairs to get rid of radicals in the denominator in your past. And it might bother you a little bit, but we have a radical in the numerator, and I just need to get rid of something. I need something to work out for me. So sometimes we use conjugate pairs in the numerator as well. So I'm going to go ahead and do that. I'm going to multiply by the conjugate pair of 2 minus root x, which will be 2 plus root x. And remember, I can multiply by that as long as I multiply both the numerator and the denominator by that, because that's like multiplying by a magic name for 1, and we're allowed to multiply by 1. It doesn't change our function. In the numerator, I'm going to go ahead and FOIL or distribute. So I have 2 times 2, which is 4. Sorry. This is still a limit. Minus 2 root x plus 2 root x minus root x times root x would be x. And then in the denominator, I'm going to just leave things the way they are. And the reason I'm leaving things the way they are rather than foiling out the denominator is that foiling can get complicated here. And what I'm hoping happens is that something cancels. So I notice that these subtract to make 0, so they're gone. And in the numerator, I'm left with 4 minus x. I also have 4 minus x in the denominator. If I had FOILed out the denominator or multiplied out that denominator, I would have lost sight of the fact that I had a 4 minus x. But this way, I know that I have a 4 minus x in both the numerator and the denominator, so those can cancel. Remember, when everything cancels, when you have fractions like this, that's a 1 in your numerator. So now I can plug in my x equals 4, and I get 1 over 2 plus square root of 4, which is 2, so I have 1/4 for my limit. The second method on this page is expansion. I see this as just something that's too complicated to look at, but I do know that if I plug in 0, I'm going to get 36, because negative 6 squared is 36, minus 36, which is 0 over 0. So I know it's indeterminate. And then trying to figure out what to do, my first thought is, well, maybe I could expand this out. So if I expand it out, I get x squared minus 12x plus 36, and then minus 36, and then I still have an x in the denominator. This is still a limit as x goes to 0. My 36's wind up subtracting away and making 0, so now I can factor an x out of the numerator. So I have x times x minus 12 over x. These x's can cancel, because remember, x is not 0, it's just close to 0. And now I can plug in I could do my substitution, so I have a limit of negative 12 for that problem. The last thing that you might have to do is you might have to do a common denominator. This is a fraction on top of a fraction, which is just awful to look at. I hate it, but I do notice that if I plug in 5, I get 1/5 minus 1/5, which would be 0, over 5 minus 5, which would also be 0. So it's indeterminate. And whenever I see fractions on top of fractions, I think, well, I'm just going to have to find a common denominator to make this look nicer. So the common denominator would be 5x. So I'm going to multiply this fraction by 5 over 5, which is just 1. And I'll multiply the other fraction by x over x, which is also just 1. It's still a limit as x goes to 5. So I have 5 over 5x minus x over 5x. And then all of that is over x minus 5, or on top of x minus 5. Okay. So now I'm going to rewrite this just a little bit nicer so that I can follow things better. So I'm going to write this as the limit as x goes to 5 of 5 minus x over 5x times, rather than dividing by x minus 5, I'm going to multiply by the reciprocal. So I'm going to multiply by 1 over x minus 5. And then what I notice is that this and this are not equal, but they're really close to equal. Their signs are just different. So in order to fix that problem, I can factor a negative 1 out to make them look like they're the same so that they can cancel. So it's still a limit as x goes to 5. But now if I take a negative 1 out, this would be a negative 5 plus 5. And then I would have 5x times x minus 5. And now I notice that these are the same thing, so these can cancel. They're just written in a different order. And now if I plug in 5, I get negative 1 over 25. So with today's lesson, there are lots of different ways of doing these problems. There are lots of different types of problems, so you definitely need to practice. But it's like all of your factoring skills from algebra class come back to haunt you as you're trying to get rid of your zero, get your indeterminate form, your 0 over 0, and turn that into a form that has an answer. That's our plan for today. Thank you.